Hello, discrete math fans. Let's talk about how to negate disjunctions and conjunctions. The way to do it is with a theorem. It's called De Morgan's laws. Essentially, the negation of an AND statement is logically equivalent to an OR statement. Then you have to negate each component. Similarly, the negation of an OR statement is logically equivalent to an AND statement. Each component is negated. We can write this in symbols. It looks something like this. The negation of P and Q is not P or not Q. Notice when you negate an AND statement, you get an OR statement, and vice versa. Now we're not going to prove these right now, but you might take a moment to try to write out truth tables to prove that these are logically equivalent. Let's write some negations of some sentences. I'm going to eat a turkey sandwich or a salad. So the negations are going to be, I'm not going to eat a turkey sandwich and I'm not going to eat a salad. The other one is, the dog did not wake up or the cat ate. So notice that whenever we negate an OR, it turns into an AND. When we negate an AND, it turns into an OR. And then we have to negate the component parts. ANDs turns into ORs, ORs turns into ANDs upon negation. All right, let's try something with mathematics. Let's write the negation of the sentence -3 less than or equal to x less than 5. Now, if you have a compound inequality, this is really an AND statement. -3 less than or equal to x and x is less than 5. Compound inequalities are always AND statements. All right, so if we want to negate this, we're going to use De Morgan's laws. So we start with this. So we write out our compound inequality and rewrite it as an AND statement. Then De Morgan's laws turn that into an OR statement. And then finally, we're going to have to take the negation of each one of these pieces. So when we negate -3 is less than or equal to x, the negation of that would be -3 is bigger than x. And when we negate x is less than 5, that turns into x is greater than or equal to 5. It's worth pointing out that the final thing we come up with cannot be written as a compound inequality. That's because the final thing that we have is an OR statement. Compound inequalities are always AND statements. All right, that's all for now.